a little more complex factoring when we have to work with squares and trinomials. So the first one that we're going to look at is difference of squares. So, well, let's get down to it. So we start with an a squared minus b squared. When we take the square root of those two terms, we end up with a minus b. But because it is a difference of squares, one of those factors must be an a plus b, so that our middle term is canceled out. So, and always, first and foremost, we always check for a GCF first. Okay, so our very first one, a. We have x squared minus 25. They have nothing in common. So the very first thing that we're going to do is we're going to take a look at them and we're going to go, okay, well, I'm going to take and square root both of them. So the square root is going to be x, bring down that minus, square root of 25 is 5. And then, of course, because it is a difference of squares, it is going to be x plus 5. All right, b, x squared minus 225. Again, I take a look. There is no GCF between them. So I'm going to take the square root of the first and second term so that I get an x minus the square root of 225 is going to be a 15. And put my x plus 15 at the end. All right, c, 3x cubed minus 27x. So it might be a binomial, but I need to take a closer look at it because it's a cube. So I'm going to take a look at both terms and I'm going to see, do they have a GCF? In this case, they do. So I'm going to end up pulling out a 3x out of both of them. 3x goes to the front. And I end up with an x squared minus 9. Now, I'm not done. I take a look at that x squared minus 9 and I go, okay, can I take the square root of those two things? I can. So I bring that 3x down. And I know that the square root of x squared is x, minus square root of 9 is 3, and I add my x plus 3. And this is my final answer. Again, look at D. I have 9x squared minus 144y squared. Now, I know I can take the square root of both of those terms, but first, I always look for a GCF between them. So I'm going to look at 9 and 144, and I'm going to see if maybe 9 can go into 144. And in this case, if I do 144 divided by 9 in my calculator, I know that I can pull out that 9. And what's left over is x squared minus 16y squared. Now, we always look for a GCF first so that this eliminates any headache or confusion at the very end of our problem. So now, again, I'm going to take a look at what's inside of my parentheses and I'm going to figure out, can I go any further? X squared minus 16y squared. Can I take the square root of those two things? I can. So I take the square root so that I get 9. X squared is going to be an x. Square root of 16y squared is going to be a 4y. And then I have x plus 4y. Now you might be wondering, well, why did I not just start from the beginning? So I'm going to show you on the side. I have 9x squared minus 144y squared. I take the square root of both. I end up with a 3x minus 12y. And again, 3x minus 12y. I have to be able to look at that 3x minus 12y, or plus 12y, and see that, okay, that 3 and that 12 also have something else in common. They both can have a 3 pulled out. So again, I have to know that I'm not pulling out one 3, I'm actually pulling a 3 out of the front one. and I'm pulling a 3 out of that last one. So that becomes a 3 times 3 outside, and then x minus 4y, x plus 4y. Okay, so this eliminates a little bit of a headache at the end. Remembering I'm pulling out 2 things, not just one. So I go ahead and look for GCFs at the very beginning of my equations or my expressions, so that everything is kind of streamlined. So now we're going to look at a perfect square trinomial. And you might be going, okay, well, how is this different than a regular trinomial? So what I look for is my first and my last terms. I see it's a trinomial, but I want to know, okay, can I take the square root of those 2 things? If I can take the square root of those 2 things, then I know that I have a perfect square trinomial. So what do? Well, if I have a squared, well, yeah, my answer will be an a plus b squared or an a minus b squared, depending on if I can do a squared minus ab plus b squared. Oh, sorry, that's plus. And this is going to be a squared minus ab plus b squared. Okay, so looking at question 1, I have my first is x squared and I have a 4. Can I take the square root of those 2 things? In this case, I can. So what I'm going to do is the square root of x squared is x. The square root of 4 is 2. However, which sign do I use? Well, it's all dependent on the sign in the middle. That sign in the middle tells me what my parentheses are going to look like. So I know I'm going to have an x minus 2, and to finish it off, because it is a perfect square trinomial, it will have a square on the outside. All right, B. I have 2x squared, 20x, and 50. What's the very first thing that I always look for? A GCF. So I'm going to pull a 2 out. This leaves me with an x squared plus 10x plus 25. Now, again, I take a look at what's inside of my parentheses and I go, okay, can I take the square root of the first and the last? In this case, I can. So I know I'm going to take the square root of x squared and 25. So I bring that 2 down. I have an x. Again, my sign was a plus, so I'm going to have a plus 5 with a square on the outside. And this is my final answer. C. I take a look. Okay, can I square, well, is there a GCF? 4, 4, and 1? No. Can I square the first term and the last term? Yes. Yes, I can. I can take the square root of 4 and I can take the square root of 1. So I know I'm going to end up with a 2x. Remember, that's a minus. Square root of 1 is 1 squared. D. I have a 9x squared, 12x, and a 4. Can I take the square root of the first term and the last term? Yes. So I end up with a 3x, a positive sign. Square root of 4 is 2, and I square it. All right. Now we're going to move on to a difference of cubes. First thing I notice, it's a binomial, and it will tend to start with a cube. So I know that because it's a binomial that is subtraction, and it's a cube, then it's a difference of cubes. So I have an a cubed minus b cubed. And I know that when I take the cube root, that will be a minus b. And for my second set of parentheses, I'm going to square the first term, multiply them together. Multiply them together, square the last term, and then change the sign in the middle. So I'm going to take the cube root, and then I'm going to square, multiply, square, and then change my sign. So looking at A, I'm going to see that I have a binomial, and I can take the cube root. So again, I have a binomial, take the cube root. Cube root of x cubed is just x. My sign is a minus. Cube root of 1 is 1. So again, I'm going to square, multiply, square, change my sign. Square the first term is x squared. Multiply them together and I get a negative 1x. Square the last term and I get a positive 1. And I'm going to go back and change my middle sign. So square, multiply, square, change my sign. All right, B, 8x cubed minus 1. I can take the cube root of both. Cube root of 8 is just 2x minus 1. Now I'm going to square the first term. The square of 2x is going to be 4x squared. Multiply them together. 2x times a negative 1 is minus 2x. Square the last term, so a square of negative 1 is going to be a positive 1. Go back and change my sign. Okay. Part C. I look at it and I go, okay, I have 27x cubed and 64y cubed. Before I do anything, I'm going to go and see, do they have anything in common? So I'm going to double check in my calculator to make sure that 3 that goes into 27 does not go into 64. And then I'm going to figure out, can I take the cube root? In this case, I can take the cube root of both. 27x cubed, the cube root is going to end up being a 3x. Cube root of 64 is going to be a 4, so minus a 4y. Now remember, square, multiply, square, change your sign. So square of the first term is going to be a 9x squared. Remember, you're squaring both parts. Multiply them together. 3x times a negative 4y is going to be a negative 12xy. And we square that last term. Negative 4y squared makes a positive 16y squared. Then we go back and we remember, change my middle sign. So square, multiply, square, change your sign. It works the exact same way for the sum of cubes. Okay? Very similarly, I have an a cubed, this time a plus b cubed, so that I get a plus b when I do the cube root. And still, I get an a squared, an a times a b plus b squared. And then, of course, if I would have multiplied them together, it would have been a positive, but I changed my sign, so it'll be a minus. This is where using pencil comes in handy. So, I cube root. Just like I did my previous problems, I cube root. I get x plus 8 for my first parentheses. Now I square, so I get x squared. I multiply 8 and x to get a plus 8x. I square my last term. 8 squared is 64. But of course, I have to go back and change my sign. So square, multiply square, change the sign. B. I take the cube root. I get y plus 15. Sorry, y plus 5, not 15. Y plus 5. Now again, I square to get y squared, multiply to get a 5y, square to get a 25. But I go back and I'm going to change that plus 5 to a minus 5. All right, C. 16x to the fourth plus 54x. Right off the bat, I should go, okay, they have a common denominator. Or they have a common denominator. They have a GCF. They have a greatest common factor. I know at minimum it's x, but I'm going to have to double check the 16 and the 54. I know I can pull out a 2x out of both. So I get my 2x out front. And then I end up with an 8x cubed and a 27. So I'm going to work with what is in parentheses. So I look at it and I go, okay, it's still a cubic. I know it's a sum of cubes. So I'm going to take the cube root. So I take the cube root. I get a 2x. And then I take the cube root to get a 2x plus 3. But then I'm going to only deal with the square multiply square of the first parentheses. So I'm going to square that 2x to get 4x squared. Multiply 2x and 3 to get 6x. Square that last term to get a plus 9. But go back and make that a minus 6x plus 9. So square, multiply square, change our sign, and make sure we always carry down our GCF for a final, very long answer.